Neon lights generally require separate neutral and ground wires. This is due to safety considerations, where the neutral wire carries current back to the service panel, while the ground wire provides a low resistance path to earth in case of a fault. This prevents electrical shock or fire by diverting excess current away from the equipment. In terms of proper circuit completion, neon lights have a transformer that steps up the voltage to create the characteristic glow. The neutral wire completes the electrical circuit by connecting the transformer to the neutral bus in the service panel, while the ground wire provides a reference point for the transformer. It is possible to put more than one neon sign on a circuit, provided that the circuit has sufficient amperage capacity. The total amperage draw of all neon signs on the circuit must be within the circuit's rating. The circuit's voltage also needs to be adequate, because neon lights typically operate at a specific voltage, so the circuit must provide the required voltage to all signs. Proper wiring must be used, and each neon sign should be wired with its own separate neutral and ground wires. The connection to the circuit should be made through a circuit breaker or fuse that is sized appropriately for the total amperage draw. It is important to note that the specific requirements for wiring neon lights may vary depending on local electrical codes and the specific type of neon sign used. Always consult with a qualified electrician to ensure proper and safe installation. Let's delve deeper into the specifics of neon light wiring and circuit considerations. Firstly, the separation of neutral and ground wires is a fundamental safety practice in electrical systems, and neon lights are no exception. The neutral wire's primary function is to provide a return path for the current flowing through the neon sign's transformer. This ensures the circuit is complete and allows the transformer to operate correctly. On the other hand, the ground wire serves as a safety net. It's connected to the earth and provides a low impedance path for fault currents. If there's an insulation failure within the neon sign or its transformer, the fault current will flow through the ground wire back to the source, tripping the circuit breaker or fuse and preventing a potentially dangerous situation like electric shock or fire. Secondly, regarding the installation of multiple neon signs on a single circuit, there are several factors to consider beyond just the total amperage draw. The National Electrical Code, or NEC, provides guidelines for circuit loading. Generally, for continuous loads like lighting, the NEC recommends that the load not exceed 80% of the circuit's rating. This means that on a 20 amp circuit, the total continuous load, including the neon signs, should not exceed 16 amps. It's crucial to calculate the total amperage draw of all the neon signs you plan to connect to the circuit. The amperage rating of each sign is usually printed on its nameplate or transformer. Add up the amperage of all the signs, and make sure it's within the 80% limit of the circuit's breaker or fuse rating. The voltage supplied to the neon signs is another critical consideration. Neon signs are designed to operate at a specific voltage, typically 120 volts in residential settings. The voltage supplied by the circuit must match the voltage requirement of the signs. If the voltage is too low, the signs may not light up properly or may exhibit reduced brightness. If the voltage is too high, it could damage the signs or their transformers. Therefore, it's essential to verify the voltage rating of the neon signs and ensure that the circuit provides the correct voltage. Thirdly, proper wiring techniques are paramount for safe and reliable operation of neon lights. Each neon sign should have its own dedicated neutral and ground wires that run back to the service panel. This ensures that each sign has a direct and uninterrupted return path for the current and a reliable ground connection. Avoid sharing neutral or ground wires between multiple signs, as this can create problems with voltage drop, ground loops, and increased risk of electrical shock. The connections to the circuit should be made using appropriate wiring methods and connectors. Use wire sizes that are adequate for the amperage draw of the signs. Consult the NEC for the correct wire size based on the amperage and the type of insulation. Use wire connectors that are rated for the wire size and the environment. Ensure that all connections are tight and secure to prevent loose connections, which can cause overheating and electrical hazards. The circuit should be protected by a circuit breaker or fuse that is sized appropriately for the total amperage draw of the signs. The circuit breaker or fuse should be installed in the service panel and should be readily accessible. If the circuit breaker trips frequently, it's a sign that the circuit is overloaded or there is a fault in the wiring. In this case, you should reduce the number of signs in the circuit or have the wiring inspected by a qualified electrician. In addition to these technical considerations, it's important to be aware of the local electrical codes and regulations that apply to neon sign installations. Electrical codes vary from jurisdiction to jurisdiction, and they may have specific requirements for wiring methods, grounding, overcurrent protection, and signage. Before installing any neon signs, it's always a good idea to check with your local building department or electrical inspector to ensure that your installation complies with all applicable codes. Finally, when working with electricity, safety should always be your top priority. If you're not comfortable working with electrical wiring, or if you're not sure how to properly install neon lights, it's best to hire a qualified electrician to do the job. The electricians have the training, experience, and tools to safely and correctly install electrical wiring and equipment. They can also ensure that your installation complies with all applicable codes and regulations. Some additional points to further clarify the topic: consider the transformer within each neon sign. These transformers are often high voltage transformers that step up the voltage from the standard 120 volts to several thousand volts needed to ionize the gas within the neon tube and create the light. Due to these high voltages, it is even more important to have proper grounding to mitigate risks of electrical shock. Also, consider the type of neon sign, because there are different types, such as those used in commercial signs, decorative lighting, and art installations. The wiring requirements may vary slightly depending on the type of sign. Always refer to the manufacturer's instructions and consult with a qualified electrician to ensure that you are using the correct wiring methods for your specific neon sign. When planning the layout of your neon signs, consider the proximity to other electrical equipment and potential sources of interference. Neon signs can generate electromagnetic interference, which can affect the operation of sensitive electronic devices. Keep the signs away from sensitive equipment or use shielded wiring to minimize interference. Remember that modifying existing electrical circuits can have consequences for the entire electrical system. If you're adding neon signs to an existing circuit, make sure that the circuit is not already overloaded and that the wiring is in good condition. If the wiring is old or damaged, it may need to be replaced to ensure safe and reliable operation. If you live in an older home with outdated wiring, it may be necessary to upgrade your electrical panel to accommodate the additional load of the neon signs. This may involve adding new circuits or increasing the amperage rating of the panel. Upgrading your electrical panel can be a significant expense, but it's a worthwhile investment in safety and convenience. If you are doing any electrical work, be sure to follow these basic safety precautions. Firstly, always turn off the power to the circuit at the circuit breaker before working on any electrical wiring. Secondly, use insulated tools to prevent electrical shock. Thirdly, never work on electrical wiring when you are wet or standing in water. Fourthly, wear appropriate personal protective equipment such as safety glasses and gloves. Fifthly, if you are not sure how to do something, ask a qualified electrician for help. Also, remember that it is important to understand that neon signs are not energy efficient. Neon signs consume a significant amount of energy, especially if they are left on for extended periods of time. If you're concerned about energy consumption, consider using LED signs instead. LED signs are much more energy efficient than neon signs and can save you money on your electricity bill. You should also know that neon signs contain mercury, which is a hazardous substance. When disposing of old neon signs, it's important to follow proper disposal procedures to prevent mercury contamination. Contact your local waste management agency for information on how to properly dispose of neon signs in your area. When installing neon signs outdoors, it's important to use weatherproof enclosures and wiring methods to protect the signs from the elements. Exposure to rain, snow, and sunlight can damage the signs and create electrical hazards. Use weatherproof junction boxes, conduit, and wiring to ensure that the signs are protected from the weather. When inspecting neon signs, look for signs of damage, such as cracked or broken tubes, loose wiring, or corroded connections. If you find any damage, repair it immediately to prevent electrical hazards. Regular inspections can help you identify potential problems before they become serious. Consider the use of a ground fault circuit interrupter, or GFCI, protection for neon sign circuits, especially if they are located in damp or wet locations. GFCIs are designed to detect ground faults and trip the circuit breaker, preventing electrical shock. In summary, installing neon signs requires careful planning and attention to detail. By following these guidelines and consulting with a qualified electrician, you can ensure that your neon signs are installed safely and correctly. Remember that safety should always be your top priority when working with electricity. Always turn off the power before working on any electrical wiring, and if you're not sure how to do something, ask a qualified electrician for help. Let us add some additional clarifying points here. For example, let's say you have a hypothetical situation where you have a 15 amp circuit. In this example, we can calculate the maximum allowable load for continuous use on that circuit. As previously stated, the NEC allows continuous loads to only reach 80% of the circuit capacity. Thus, a 15 amp circuit could handle a maximum of 12 amps continuously. Each neon sign consumes a certain amount of power, which is often specified in watts. To determine the amperage draw, you would need to divide the wattage by the voltage, which is typically 120 volts in the United States. For example, if you have a neon sign that consumes 100 watts, then the amperage draw would be 100 watts divided by 120 volts, which equals approximately 0.83 amps. If you want to connect multiple neon signs to the same circuit, you must add up the amperage draw of all the signs to ensure that the total does not exceed the circuit's capacity. If you have 3 neon signs, each drawing 0.83 amps, the total amperage draw would be 2.49 amps. This is well within the capacity of a 15 amp circuit, as long as there are no other significant loads on the same circuit. It is important to note that the NEC also has rules about dedicated circuits for certain types of equipment. For example, in a dwelling unit, certain appliances, such as refrigerators and washing machines, require their own dedicated circuits. Adding neon signs to these circuits could overload them and cause problems. Always refer to the NEC for specific requirements regarding dedicated circuits. Also, the type of wire used to connect the neon signs is also important. The wire must be of the correct gauge or thickness to handle the amperage draw of the signs. The NEC specifies the minimum wire gauge for different amperage ratings. Using wire that is too small can cause overheating and potentially lead to a fire. Additionally, the wire must be suitable for the environment in which it is installed. For example, if the neon signs are located outdoors, the wire must be rated for outdoor use and be protected from moisture and sunlight. The type of conduit used to protect the wiring is also important. Conduit is a pipe or channel that is used to enclose and protect electrical wiring. The NEC specifies the types of conduit that are permitted for different applications. For example, rigid metal conduit is often used in commercial and industrial settings because it provides excellent protection against physical damage. Electrical metallic tubing is a lighter weight type of conduit that is often used in residential settings. The connections between the wire and the neon signs must be made using approved connectors. These connectors are designed to provide a secure and reliable electrical connection. There are many different types of connectors available, and it is important to choose the correct connector for the specific application. For example, wire nuts are commonly used to connect wires together in junction boxes. Crimp connectors are often used to connect wires to terminals or equipment. The NEC also has rules about the spacing of electrical boxes. Electrical boxes are used to enclose and protect electrical connections. The NEC specifies the maximum number of wires that can be installed in an electrical box, as well as the minimum spacing between boxes. This is to ensure that the wires do not overheat and that there is enough room to work on the connections. The use of surge protection is also recommended for neon sign circuits. Surge protection devices are designed to protect electrical equipment from voltage spikes or surges. These surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices can help to prevent damage to the neon signs and other electrical equipment. In addition to the NEC, there may be other codes or regulations that apply to neon sign installations. For example, some cities or counties may have their own electrical codes that are more stringent than the NEC. It is important to check with your local building department to determine which codes and regulations apply to your project. Hiring a qualified electrician is the best way to ensure that your neon sign installation is safe and compliant with all applicable codes and regulations. An electrician has the knowledge, skills, and experience to properly design and install electrical systems. They can also help you to troubleshoot any problems that may arise. When hiring an electrician, be sure to check their credentials and make sure that they are licensed and insured. Also, get a written estimate before the work begins so that you know exactly how much the project will cost. Understanding the principles of electrical safety is crucial for anyone working with electricity. Electricity can be dangerous if it is not handled properly. It is important to follow all safety precautions and to use common sense when working with electricity. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Let's now explore some of the practical aspects of wiring neon signs, and we will use examples to help make sure that the concepts are crystal clear. Imagine you are installing several neon signs in a small business. Before you start, you need to plan the electrical layout. This involves determining the number of circuits you will need, the location of the electrical boxes, and the routing of the wiring. You should start by drawing a diagram of the electrical layout. This diagram will show the location of all the electrical components, including the neon signs, the electrical boxes, the circuit breakers, and the wiring. Once you have a diagram, you can start to calculate the load on each circuit. This involves adding up the amperage draw of all the neon signs and other electrical devices that will be connected to the circuit. As previously mentioned, the total load on a circuit should not exceed 80% of the circuit's capacity. If the load exceeds this limit, you will need to add another circuit or reduce the number of devices in the circuit. Once you have determined the number of circuits you will need, you can start to install the electrical boxes. Electrical boxes are used to enclose and protect electrical connections. The electrical boxes should be mounted securely to the wall or ceiling. The wiring should be run through conduit from the electrical box to the neon sign. The conduit should be secured to the wall or ceiling using appropriate fasteners. The connections between the wire and the neon sign should be made using approved connectors. These connectors should be installed according to the manufacturer's instructions. Once the wiring is complete, you can install the circuit breakers in the electrical panel. The circuit breakers should be sized appropriately for the load on each circuit. The circuit breakers should be labeled to indicate which circuit they protect. Before turning on the power, you should inspect the wiring to make sure that everything is connected properly. You should also test the circuits to make sure that they are working correctly. A multimeter can be used to measure the voltage and current in the circuits. If you find any problems, you should correct them before turning on the power. Once you are satisfied that everything is working correctly, you can turn on the power to the neon signs. You should then observe the signs to make sure that they are lighting up properly. If you notice any problems, you should turn off the power and troubleshoot the wiring. Here are some additional tips for wiring neon signs. Always use the correct wire gauge for the amperage draw of the signs. Use approved connectors for all electrical connections. Protect the wiring with conduit. Install circuit breakers that are sized appropriately for the load on each circuit. Inspect the wiring before turning on the power. Test the circuits to make sure that they are working correctly. Follow all safety precautions when working with electricity. Remember, when dealing with neon signs, or any electrical work for that matter, if you are not experienced or uncertain about any of the steps, it is always best to consult with a qualified electrician to ensure the work is completed safely and according to the prevailing electrical codes.